And if they concur, then the reverse is also true. So it's an interesting fact. I'm not going to go too much into it, just because I want to move on to the next one. But you can look it up on Wikipedia. It's really interesting. Yeah. So, okay. So this one I think might be a little easier. Let's see. So we have a scalene triangle ABC, and we have the orthocenters O and H. I'm sorry, circumcenter and orthocenter. Okay. So there's the orthocenter, and then P it satisfies, so AHP is equal to POA. Okay, so we have like two isogonal lines. So no, so we basically just draw the angle bisector because AH and AO are isogonal, right? So P is basically any point on the angle bisector of ABC. And then M is the midpoint of OP. So it feels kind of like Symedians here. BM and CM intersect the circle at X and Y. Okay. So that's X. This is Y. And we want to show XY passes through the circumcenter of APO. All right, let me hide a couple things. So, I mean, AP is the angle bisector, so it passes through the midpoint of this arc. So you could just call this D. And let me hide some things. And then I also want to draw PO. So M is the midpoint of PO. AP and B are collinear. CM and Y are collinear. BM and X are collinear. We don't even really need H because, I mean, we know, all we really need to know is P lies on the angle bisector of ABC, right? Point H we don't even really need. So I'm going to draw the circumcircle of APO. And let's draw the center of that circle. And
I think he's not right.
Oh, the figure's not right?
Yeah, P.
So P satisfies AHP is equal to POA. Oh, AHP. I'm sorry, you're right. Okay. So I'm going to have to redraw most of this. So AHP equals POA. Let me think how to do that.
You can draw the circumcircle of AHO.
Okay.
And choose a point P. But not that side.
Yeah, on this side. Yeah. So P is somewhere here. And then M is the midpoint of OP. Let me Whoops. Sorry. Maybe something like that. Well, I think that's good. And then BM and CM intersect at X and Y, intersect the circle at X and Y. Let me move that away a little bit so it doesn't look like they concur. Maybe like that. So BM intersects it at X. And CM intersects it at Y. And we want to show that XY passes through the circumcenter. Okay, so the center of that circle. Yeah, this doesn't look like a hard problem, but let's see.
Well, we draw wrongly again.
We draw what? Oh, we drew it wrong? Oh no.
Yeah.
P lies inside AHO. Oh, okay, but we might be able to just move around the points. Let's see. So we wanted AHP to equal POA. How do we do that if P lies inside triangle AHO?
Actually, I was wrong. It doesn't lie on this circle.
It doesn't mean that it is on the circle. Yeah.
Oh. So AHP equals POA.
That mean we just need draw this some circle through point H and O and cut AH and AO at 2 points, and the intersection of O, let's say E and F, and intersection of OE and HF is point P.
P, yeah.
Okay.
Yeah. You must erase delete that point P.
Okay. All right.
And the circle as well. We don't need circle. Yeah.
Okay. So you were saying
We draw a circle through H and O.
okay, just any circle I want, right?
Yeah. 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 No, we need to let it cut AH and AO as well.
Okay, we want to see where it cuts AH and AO.
No, I think you should then let the D is lie on AC. Just choose.
Okay. So we want to see where it cuts AH and AO?
Yeah, what? No, it must cut inside the AH and AO. Yeah.
Okay.
Yeah.
All right.
Yeah. Yes, and OE cut HF at the point P.
Okay.
Now you can hire the circle and another point.
All right. So then APH is equal to, but AHP is POA. Okay. All right. Well, actually, you know what? I'm going to draw just this point. This point. Sorry, because sometimes these points are useful. So we'll draw this point, and this point, and yeah, point D. I'm just going to hide it for now. Okay, so M is the midpoint of OP. BM and CM intersected at X and Y. And we want to show that XY passes through the circumcenter of APO. Okay. Okay. So now I think we've drawn the problem correctly. All right, so AM is the median of APM. So maybe we could do something with symmedians. I don't know.
Let HP cut the other circle of APO.
Okay. So point L.
No, HP.
Oh, HP. Okay. Sorry. Let me shrink the diagram a little bit. Oh yeah, I think it's some. Yeah. All right. And yeah, I could probably move point D around too. That might help a little bit. Oops. Yeah, hold on just a second. I'll draw the line XY. Make this a little smaller. Okay, so HP and then XY.
And you also intersect HP.
Yeah. So that's N. All right, and the problem fits pretty well.
AHN is an isosceles triangle.
AHN is isosceles.
Yeah.
All right. Yes. You want me to leave point L there? We'll just leave it for now. So let's see.
Hide D. And hide the D.
Yeah. Actually, I could just, there we go. So yeah, that's a good way to use that fact because AHN is isosceles. Let me see if this helps at all. No. Are these concurrent actually? I don't think so, but we'll just play around with it to see. No. Oops. I didn't want to do that. I'm going to delete this. AHN is isosceles because angle AHANP is equal to angle AOP. And then the question says AOP is equal to AHP. Interesting. That was harder than I thought.
You can define K as the perpendicular from M to OP, and it cuts XY at K prime.
Okay. So we could call it K prime. So I'm going to do what you said. So
we want to prove that K prime O equals to K prime A.
all right. So we draw the perpendicular from M to PO, and we let it meet XY at K prime. And then we want to show that K prime A is equal to K prime O, basically. So yeah, I've seen a couple problems where it's like you take, okay, yeah, so we have CM and BM. I wonder if it's worth like drawing the symmedian, because AM is a median. Maybe it's worth drawing the symmedian. Don't know.
ENF can be useful.
Can we use what?
ENF.
Did you say ENF?
Yeah. Oh, and the circle.
All right.
Can you define the midpoint of XY?
Yeah.
Then we will have OM that point, and K will be like concyclic. OM KK prime. Yeah, we want to show that OM KK prime is concyclic.
Okay. We'll just call it X.
OM X K prime.
All right. Because yeah, they'd both be perpendicular.
Yes, because they are perpendicular.
So we want to prove that the midpoint of AO is on this circle. All M x2 K prime.
Hold on one sec. Sorry, it's just, oh, I gotta call it Z because we already have X and Y. Okay. So you want to prove the midpoint of OK prime.
AO, midpoint of AO.
Okay. Midpoint of AO would lie on that circle. Yeah.
You can delete circle for now. Circle of EFOH.
Okay. But I consider K prime as the center. So Vance just asked me a question. K prime, we've redefined it to be where the perpendicular bisector of PO meets XY.
It is enough to show that OM, Z, and K prime are concyclic, right?
Yeah, that should.
Then we want the angle OZM equals the angle OK
OK prime M. Oh, sorry, you cut in and out a sec. It was hard to hear you for a second, but you said you want to show.
The angle OZM is OK prime M, right?
Yeah, if we can show that,
No,
that would
actually,
solve it.
we want to prove that V is on the circle. V.
Oops, sorry. So yeah, how do we use that AHN as isosceles? So AH, I don't know if this would work, but this would help, but AH is twice OK. I gotta keep renaming things, sorry. Like U. So AH is twice OU. So that would mean AN is twice OU.
Maybe de facto over BC.
Yeah, that might help. So AN is OO prime. And AO is the radius of the circle. So maybe like NAO is congruent to O prime O and then something else. I don't know. Maybe O prime O X or something. Yeah, I'm not sure. Let me check it out. So I kind of like that idea. I knew I knew it would measure it the wrong way. But OAN, and then Sorry. See what I'm trying to get congruent triangles. So that's 141 degrees. Let's try this. It's 116. Maybe let's see HOO prime. It's so close, but it doesn't equal. I'm not sure how useful this would be.
Can you intersect MK with BC?
Yeah. Let me move things over a little bit. Maybe like that. Call it W.
I actually don't know, is it useful, but by Butterfly Theorem, we have MW equals MK prime.
Interesting. MW is equal to MK prime. So that does seem like it might be useful. Yeah, and you got that because since OM is perpendicular to this, basically if we drew the whole chord, M would be the midpoint of it. So then use the butterfly. It's interesting. I'm going to delete this, the angle.
Is K prime P is equal to KO or just?
K prime P and KO, K prime O.
Yeah.
They'd have to be equal if the problem is true.
Yeah, they're equal.
Okay. So who's on their iPhone? I'm not sure who it is. Sorry. Okay, so you have K star as the center, then that's all right. I forgot, what is Z? Oh, Z is the midpoint of XY. Okay.
if we kind of show that the center's reflection to OP lies on BC, then we are done, right?
Yeah, I think that would solve it by the converse of the butterfly theorem that you just mentioned. So yeah, if this is the center of the circle, then yeah, I mean it depends how we define things. So Urajan just asked me, but if we define this as a center, then yeah, that would be cyclic. If the problem is true. Do we want to just let K be the center instead of the, like, do we think that's easier instead of where the perpendicular bisector meets? I'm not sure. And then yeah, then we could just show that if you reflect it over OP, we would want to show it lies on BC.
Oh, I think I found something interesting.
Okay.
VW is actually the center of the circle POO prime.
Did you say so? PO
W.
prime. Ah, so W is the center of that circle.
Yeah,
Interesting.
because it's the intersecting point of perpendicular bisector OP and perpendicular bisector
O
OP.
prime. Interesting. So AN, so W is the center of that circle, and AN is equal to OO prime.
I guess if we show that the reflection of A to PO lies on that circle, then we are done.
Let's see.
By the symmetry, basically.
Is it the intersection of those two circles? Let's see. Well, it would be, yeah. So we want to show that the point where those two circles intersect is the reflection of A over OP. Yeah. Interesting. Yeah, it's hard to get a good diagram, I'm sorry, but there's just so many points, but maybe I could delete some of the points now that we figured out some stuff. So, sorry, Urajan. So K prime, you're defining it as the intersection of X, Y, and this perpendicular bisector of OP. Yeah. Yeah, if OMZ K prime is cyclic, I think that should be enough. But I like this idea here. I like this idea because it uses the fact that, or it trices that AN is equal to OO prime. So I wonder if these circles are the same size. I could probably check that. Length. So that's 4.63. Yes. So I don't know if that's, oh, well, that would be true if what we're trying to show is true. Well, yeah, so those circles, we kind of want to show that they're the same size. So we know that AN is OO prime. And can we show that like angle APN is equal to angle OPO prime. So that's kind of interesting because, yeah, those circles are the same size. That's like really surprising to me. Is that? Yeah, that's true. Do we know OK prime P? Yeah, I'm not sure. I mean, if we could prove that, that would solve the problem. But yeah. Yeah. Let me see if I can find some congruent triangles again. So so if these circles are the same.
Michael, I think I solved this.
Okay.
Okay, so if we have angle BK prime M is equal to BAO, that will solve the problem, right?
BK prime M
is equal to BAO.
Oh, PK prime M.
Yeah, it's equal to BAO. That will solve, right?
Yeah, so let me just write that down. All right.
PAO.
PAO, sorry.
Yeah. Yeah, and PK prime M is equal to is equal to MWO.
MWO.
Because PK prime OW is a rhombus.
Oh, but how are we defining K prime? Are we defining
K prime is the perpendicular from M cut X Y.
Okay.
Okay, so as
so how do you know it's a rhombus?
Because MK prime is equal to MW as
the butterfly by the butterfly theorem.
Yeah,
like
butterfly theorem.
Malik said. Okay.
Yeah. So PK prime M is equal to OWM, right?
Yeah.
And OWM is equal to OUM.
OWM is equal to OUM.
Because WMO is 90 degree and OUW is 90 degree too. So we need angle PAO is equal to MUO. Okay, so let's say we will prove triangle FAP.
Okay.
FAP is similar to FAP is similar to OUM.
Okay.
Okay, so because the first thing is that angle MOU, right? MOU is you say EPM is collinear. Can you draw EP?
Hold on one sec. EP and M?
Yeah, because EPO is a collinear.
Okay.
Okay, yeah, right.
Sorry.
Yeah. So
GeoGebra won't let me. Hold on. There we go.
okay, so angle MOU is equal to angle AEO, right? Because OU is parallel to AH, and AEO is equal to AFH.
Yes.
Yeah. So we need AFA over FP is equal to OU over OM.
Let me unhide this circle just because we end up using like in one of the things you said. Okay.
Yeah. So can you write down? We need
yeah. So they basically so I'll start by writing what Melek said. So by the Butterfly Theorem.
Yes.
We have K prime M equals MW. And so that means that K prime PWO is a rhombus. And so then we have angle K prime M is MWO, which is MUO. So MWO, which is MUO.
Yeah.
And then we want to show AFP is similar to MUO.
Yes. AFP is similar to UOM.
Sorry,
AFP.
AFP is similar to UOM.
Yeah.
And then for
we have angle AFP.
So we have angle MOU is EP, which is AFP. Okay,
yeah.
So
yes.
All right.
So and then we need FA over OU is equal to FP over OM.
FA over OU is FP over OM.
Yeah, we need that. We need that.
Okay, so we want to show that.
Yeah.
We'll put it down here then.
Okay. So first of all, FB over OU over OM is FB over a half of OP.
FP over OM is FP over half of OP.
Yeah, OP. Yeah.
Okay.
Yeah, it is twice of FB over OP.
All right.
Yeah. Okay. So FB over OP is EF over HO.
So FP over EF.
No, FB over OP is equal to EF over HO.
Right.
Yeah. Yeah. And EF over HO is equal to AF over AH.
Okay.
Yeah. And AH is double of OU, and that is AF over OU. That will solve the problem.
Oh man, this is a really nice one. All right.
Yeah. Thanks to Alex, because of the butterfly theorem.
The butterfly. Yeah.
Yeah. I cannot see it.
Oh, Melek.
Melek.
So okay. So this implies AFP is similar to UOM. And so once we know that, then we have that angle PK prime M is equal to so then PK prime M is equal to
PAO. Yeah.
PAO.
MUO is equal to PAO. Yeah.
Yeah.
Yeah. K prime is yeah. That's very nice.
I'll put that on a separate line, and then I'm going to move on to the next problem.
Yeah. I think we should define K. Yeah.
Yeah, I think I might just skip it for now, just because to move on to the next one. Well, I'll define K prime actually. I should do that. Let's see. Okay, so yeah, because people watching on YouTube might be confused. So let K prime be the intersection of XY with the perp bisector of I think it's AO. Yeah. No, MP.
No. OP.
OP, sorry. Right.
Yeah.
All right, very nice. So yeah, we never actually used O prime. It's interesting. So I'm going to move on to the next problem. So we have a quadrilateral with AC perpendicular to BB. Okay, so this is C and B can be anywhere. So yeah, we have about 30 minutes left. Whoops, sorry. Sorry about that. GeoGebra is very slippery. If you click something, I did it again. Okay, so all right, so then we draw the circumcenters of ABD and CBD. They're O1 and O2. We want to show that AO2, CO1, and the Euler line of ABC and ADC are concurrent. So really, is EF parallel to AC? Kind of looks like it. Yeah, because EF is perpendicular to BD, so it's parallel to AC. So, okay, let me rename it. So ABD, so this should be O1, and this should be O2. And the Euler line of ABC. So, so the Euler line, it's the line between O and H and the 9-point center and the centroid. So there's a couple different points on it, but so yeah, really we only have to show it for ABC, right? So I'm going to draw the orthocenter of ABC. Okay, so I'll call O the circumcenter of ABC, and I'll call H the orthocenter. Oh, by the way, this is also Taiwan 2021. I forgot to put the source. So, whoops. So all we have to do is show that AO2, CO1, and OH are concurrent, and then the same argument would hold for a triangle ABC. Yeah, well, I'm going to send out all the GeoGebra files after the session. So if you give me your email, or I already have your email, I'm going to send these files to everyone so you'll know all the problems. Okay, so we want to show that OH, AO2, and CO1 are concurrent. Interesting. Homothety between O. Oh, they're homothetic. Does that just solve the problem? O01, O2. So that's the three centers, and AHC.
You named O1 and O2 wrong. So you have to swap them.
Oh, okay. O1 is the center. Wait, are you sure? So O1 is the center of ABD.
Yeah, it's BCD.
Oh, yeah, you're right. My bad. So that's O2, and this is O1. So are you saying AHC is similar to that?
Yeah, sides are parallel. Easily we can prove 3 sides are parallel. So
Okay.
they are,
So they're parallel. So a homothency, so if all 3 are parallel, then yeah, oh, that's silly. Then it's just the Sarg's theorem. Yeah, okay. So yeah, E is also going to be on that line. Well,
no, E is wrong. We have to.
oh no, yeah, E's not on it. Yeah, but yeah, no, this one was too easy. So I'll just quickly write it up. So the sides of ABC and O01, O2 are mutually parallel. So yeah, you could use the Sarg's theorem. Well, easy to see. That's pretty easy to see. So by the Sarg's theorem, oh, I'm sorry, AHC, not ABC. By homothency or the Sarg's theorem. AO2, CO1, and OH concur. And we can use a similar argument with triangle ABC, and so that basically solves it. I'll just say which solves the problem. All right, I'm going to move on to the next one. So this is the 5th problem. This looks like a little, but let me check the other 2, see if there's like a short one, because we don't have that much time left. I think this one might be a little shorter, so we might be able to finish it. Let's see. So we have the AX circle of triangle ABC. And so yeah, I don't know the best way to draw X circles, but I'll just do it. I'll just pick a way. So that would be the X center. Yeah, X centers are hard to, because they take up a lot of space. So it's tangent at D, E, and F. Okay, let me draw those points, and I'm gonna have to rename some things. So this is D, and it's CA at E, and AB at F, and M is the midpoint of EF, so it's going to lie on that diagonal. So I'll call this like, I don't know what's a good letter for the X center. I'll just call it K. So the midpoint of EF. That's M. And then P and Q are on it. So E, P, and FQ are parallel to DM. Interesting. So I'm just going to draw the segment. And we want to draw a couple parallel lines. So we have that line and that line. And let's see. Whoops, didn't mean to do that. Let me hide that. EP and FQ. So this is Q. This is P. Let BP and CQ meet at X. This is an interesting configuration. We want to show that AM bisects XAD. Okay.
X is not that one.
Oh, sorry. Yeah, you're
BP
right.
and CQ.
There we go. All right. What else did I do? So M is the midpoint of EF, and then FQ and EP are parallel. That should be all we need, I think.
Is X on the circumcircle of ABC? It doesn't seem right, but
Let's see. No. So yeah, I can make this a little bit bigger. So we want to show AX and AD are isogonal, basically. Can we use the isogonal line lemma? But I think it would be hard to use the isogonal line lemma because BX and CD meet at B. And BD and actually, so we would have CD and BX, and then we would have BD and CX. Wait, now I'm confused.
I think we cannot use this.
The isogonal line lemma.
We will have AD as a DC median of triangle DEF.
AD is the semedian of what?
DC median of triangle DEF, right?
DEF. I think is that like a well-known fact.
Yeah,
Just since the tangents from E and F touch a D, it's It's well known, I think. Yeah.
Okay, yeah. No, I see what you're saying. Yeah. So yeah, FDEP is harmonic. So basically DM and AD are like isogonal kind of. So yeah, maybe I could draw this. Are DX and F collinear? Looks like they might be.
Not symmetric.
No, they're not true. It's not. Yeah.
Can you intersect DM and the X circle the second time?
DM, yeah. There we go. Right. So GH is parallel to EF. Yeah, it's kind of hard to see
It's enough to prove that AX, H are collinear.
AX
Yes,
and H.
yes.
Ah, so that's why you drew point H. That makes sense. So yeah, we have to use the parallelism. Maybe this is just like some angle chase.
We also have angle FDG is equal to angle EDM.
EDM is MD.
FDG.
FDG. Yeah.
Right?
Yeah. Yeah, because GH is parallel to EF. Yeah. Yeah, I feel like I'd like to use the isogonal line lemma, but maybe we could do it with X and G, because where the reflection of AD across AM, that should like pass through X, or we want to prove it passes through X. We know it passes through H.
Like maybe X and G are the isogonal conjugate with respect to triangle ABC. Can it be so?
Oh, see if they're isogonal conjugates? Yeah.
Yes. Then we just prove for BX and BG.
Okay. So if they're isogonal conjugates, you could check it this way. So I'm going to erase these lines in just a second, but yeah, let me do it like this. So if they're isogonal conjugates, then if I draw this circle, so this point, I don't think they're isogonal conjugates. Although this point didn't. Oh, maybe they are actually. This point just didn't show right. J L. So if yeah, I think they are isogonal conjugates, X and.
So no, instead of proving from A, we prove from B, and similarly, they are also from C.
Hold on just 1 second.
Okay.
So, okay, so we wanted to show that X and G are isogonal conjugates, right?
Yeah, maybe we can show BX and BG or isogonal conjugates with it. And then similarly by symmetry, CX and CG will also be, then will be done.
Okay, so if we can show that CX and CG are isogonal and BX and BG are isogonal, then that would mean that AX and AG are isogonal, and that would solve the problem. I think that has a good chance of working. Because, yeah, and I think that's true because arc FP, arc FP is equal to arc GD, right? I think that's true. So that would mean that BP, BX and BG are isogonal. And then we would want to show that arc arc DQ and arc EG are equal. So that would mean those are isogonal. Okay, so I'm just going to write an outline, but I think that solves it. Just because we're out of time. So
I think we can only just angle chase and get to the point.
Okay, so by angle chasing, so we have arc FP. FP is equal to DG.
Or is this true?
That's true, right? And so that means angle FBX is equal to DBG.
How is this true? I couldn't see.
Oh, so these arcs being equal or the angles?
Arcs.
I'm actually not sure. I kind of guessed, but FP, because we have so many parallels that, yeah, I don't know for sure. So let's see, FP is FH plus HP, which is FH plus DE. And then is FH equal to EG? Yeah.
Yeah.
FH is equal to EG. Yeah, because they're parallel. Yeah. So by angle chasing, I'll say, and using that FH equals EG. Then we have that. So So basically, yeah, angle FBX is DBG, and similarly, angle BCX is now I'm getting confused. So similarly, BCX is wait, FBX is X and G. So BCX is GCE.
Why is angle FBX equal DBG?
Because basically BF and BD are tangents to the circle. And so if FP is equal to DG, then by symmetry, because the whole thing's symmetric, because BF and BD are tangents. So if this arc is equal to this arc, then those angles will be equal. So let me, so yeah, we're out of time. I'm just going to finish writing up this last thing before I sign off. So similarly, what is it? Angle CE, I'm sorry, I'm getting confused. BCX is equal to GCE. BCX is GCE. So G and X are isogonal conjugates with respect to ABC. And so once you know that, then that pretty much proves the problem statement. So then from there it follows that AM bisects angle XAD. Yeah, we haven't used isogonal conjugates in a while, so yeah, I like this solution. All right, so we're out of time, but yeah, this was a really fun session. So yeah, that second problem was really hard. So I think it's really cool that we got through it, and we had a lot of new people participate this time. So it was fun. So if you're watching on YouTube and you'd like to join a future session, feel free to email me at mgreenb801 at gmail.com. The sessions, they're at 8 a.m. US Central Time. All right, see you next time.